wasn't here on Thursday because on Cairo, so
Hot breath.
I need to make sure you guys know chain rule. So let's do the shortcut rule first.
We don't have it.
No, you don't have it. You don't have it. So how would I rewrite this before I do the derivative? I say 3 minus x raised to what power? 1/2. Good. Now, if I do the shortcut rule, which is lovely, move the 1/2 to the front. Drop the exponent by how much? So -1/2. But am I done yet? One more thing you have to do. You have to take derivative of the outside, which is what? Sorry, derivative of the inside. Exactly. So that's just one little wrinkle you have to kind of keep in mind that, oh, okay, that's chain rule. So y prime will be -1/2 root 3 minus x. Okay, that's a shortcut rule. It's good to do that. Just make sure you got the right answer. Now, how would I do this doing the limit definition of derivative? You can also do it with x approaching a or x approaching, well, actually, no, we could do it this way because you're plugging in -6 straight up. So you're doing f of -6 plus h minus f of -6 all over h, right? Or you could do this. The limit as x approaches what?
Why -6?
Because it said so.
Oh, sorry.
Because you're told to do so. You do x plus 6. Is that right? X plus a? No, x minus 6. Wait. Sorry, I'm tripping. No, it's sx minus 6. Wait, what am I doing wrong here? Is that right? You know, forget about the is x plus 6? Let's just do it this way. Yeah. Okay. So what would I do? I would do root 3 minus -6 plus h minus what's f -6 root 9. And then what happens up top? It becomes 9 minus h, right? Minus 3. Okay, do you guys remember what to do after that? Conjugate.
Yeah,
Conjugate, right? Yeah, I don't know why I'm screwing up the alternative definition, but it's all right. We'll just do it this way. Yeah, and then you just clean it up. If you clean it up correctly, you should get a number, right? And by the way, if I were to plug in -6 into this, it would be -1 over what? So you should get -1/6, right? Cool. All right. And you wind up getting the same thing here. I don't need to follow through on it, but do expect that, right? Do expect that. This one here, average rate change, right? It's taste rate change. You know what that means. And that's just an extension of what you did in part A. So that should be pretty simple. Yeah.
Wait, can you go back?
Yeah, it's just asking to find the derivative at -6. Find the slope. Yeah. Yes. Right. I'm only ask it once. Only ask that once on the test. So I'm not gonna make you do the long way more than once, just once.
Are you able to put the work back?
just teasing. Let me take a screenshot of it. Sorry, go ahead.
How'd you get from the last limit thing on the
Oh, which on the left or right?
the left?
Left side. Okay. So go from here to here.
Well, how'd you go from there to there? Like, how'd you interpret it?
Oh,
Stop.
I just stopped. I didn't keep going. But are you asking about the setup for or the second?
Wait, so after you did that, you got that.
Okay, so I plug in -6 plus h and -6, right? And then so I actually substitute -6 plus h and -6.
Yeah.
And when I clean it up, I should get just 3 minus -6, which is 9. And minus h is minus h.
And then why'd you do this con?
Because because right now, if I plug in 0, I still get 0 over 0. I need the conjugate so I don't get that happening again. So that, by doing the conjugate here, actually, I'll just do it just so we and I'm recording, so I don't know why I did a screenshot, but I know I'm supposed to get -1/6 my answer. I expect that. So if I wrap it up, you should have limit as h approaches 0 of what? 9 minus h minus 9 over h. And see how the 9s cancel, right?
Yeah.
And then the h's also cancel. I know I skipped a couple steps here. And then if you plug in 0 for h, you're golden. You got it. Yeah. So I just want to see that process. So there's gonna be like a certain rubric that goes with it. Okay. I'll probably ask something about continuity differentiability, right? Also knowing how to identify the limit definition of the derivative. So you want to be mindful about that as well. Piecewise stuff, continuity, establishing differentiability, all that stuff there. Drawing the graph of the derivative, I'll ask that. If I give you the derivative graph, how to get back to the original. Stating whether something has a cusp, corner, vertical tangent. I think that's a good question. Doing stuff in the calculator. We've done that already. So you will, yeah. Graph calculator will be allowed throughout the whole thing. Yeah, it's graph calculator allowed throughout the whole test. I'll totally do that. These kind of questions here. So you know what? Would you want me to print this for you guys? Yeah, I'll print the answer while you guys are working. So this is yet another resource. So another resource, you have this. Trying to think. I think that's pretty much. Oh, well, this only went up to 3.2. So obviously shortcut rules you can use. I'll have some other problems where you use shortcut rules.
Looks like it's gonna be a very long test.
Well, I'll have to kind of reduce some things here.
You do this and add on more stuff. Like
I might get rid of like part B. I might get rid of number 4 actually, because that's kind of covered elsewhere. What was that?
You give me 60 minutes.
60 minutes.
Mr.
Hold on a sec. I'm also gonna ask. I may not ask number 8 though, because actually I kind of like it. Yeah, I don't know. I may not ask that one. I am gonna ask something about trig, because we did do trig, and I'll do that with chain rule. So actually, let me show you this really fast. I might do something that's designed like this here. Ooh, that's a good one. Has anyone tried this one yet? Okay, that is a
What are you talking?
triple chain.
Yeah.
Oh yeah. You guys want to see a triple chain?
Yeah.
Actually, sorry, it's a double chain. It's a double chain. It's double chain. Yeah, double chain. It's not triple, but I should do triple. Okay, how do you handle double chain, guys? Okay, so let me show you this one here. Okay, guys, quiet, please. If you're asked to find a derivative of this, think of it like this: f prime of g of h of x times g prime of h of x times h prime of x. So this is that's why I keep Barry Bonds, Babushka doll, whatever you want to call it. So this is the Giants when he's on steroids. He's all like beefed up and he's hit like 73 homers. He can't make the Hall of Fame. So that thing is like the outside function. This is f of x. These are the Pirates when he actually was a Hall of Famer still and was very skinny, but wasn't hitting home runs like crazy in the early 90s. So this is like g of x. And this is when he was like a young buck playing for Arizona State Sun Devils. I think Sun Devils. And so that's like h of x. So think of like inside, right? Think like that. I didn't save it for this, but anyway, it does help. So what's your inside, guys? What's your inside here? The 3x plus pi. That's your h of x. What's your middle? The cosecant, just the cosecant x. And then what's your f of x? X to the power 4. That's the inside. Oh, sorry, 3x plus pi. Sorry, my bad. 3x plus pi. So when you do this, here's what you're going to do. Y prime is going to equal 10 times. And actually, let me prime it first. Let me prime it. So 10 times bracket cosecant parentheses 3x plus pi bracket raised to the 4 power. So brackets parentheses help tremendously. Now worse. So what should I do first? What's my outside? It's a 4 power, right? It's like a power term. So shouldn't that go to the front? Because you're told that, dude.
It's the same thing.
It's the same thing. You're told that. I'm just doing what I'm told. That's all. Okay. So cosecant 3x plus pi.
Oh, okay.
You got it, Thomas? You're good? Okay. No worries. No worries. Yeah, just going with what I see there. Okay, do you see what I've done so far, guys? I moved the 4 to the front, dropped exponent by 1. But what's now the intermediates? What's the derivative of cosecant? Negative. Yeah, and you're gonna have to memorize those. I'm not gonna give them to you. You're gonna have to memorize them. I will give you that little cheat sheet that I promised. I mean, not for the test, but I'll print it so you guys have access to it. So that'd be 3x. So cosecant 3x plus pi times what? Cotangent plus pi again. And then finally h prime of x times 3. And you can leave it like that. You don't have to clean it up. But if you want to clean up a little more, you could say, I'll put in black, the final answer. Be 120, no, negative 120 times cosecant to the 4 power yeah. So if you think about it, in red, I will ask this on the test because this problem encapsulates 3.5 and 4.1. I take care of trig, I take care of chain. But that's how I would test that, just so you know.
In black after.
Just give me a sec. I'll explain everything in a moment. So see how I color coded it? So the outside, right? The outside is raised to the 4 power. I moved the 4 to the front, dropped by 1, kept inside intact. Then what's in the middle? Cosecant. I drew the cosecant in blue, right? Kept that inside intact. The kept that intact. The negative cosecant cotan times 3. Okay, no, sorry, the times 3, the inside, which is 3. Clean it all up, and you get this. I think what I might do, the more I think about it now, I might do this as a multiple choice question. But you still have to show me the work. But at least you have that sense of validation that, like, okay, I think I got this because I see the choice there. And by the way, remember how to verify this in the calculator? Yeah, let me show how I would type it in. So this is good that I'm doing this on video so you guys have us to watch. If I go to, so definitely that for sure. I'm gonna ask. Hold on a sec. That's gonna be math department. And just need a few more minutes and I'll let you guys get to work. I kind of think like now I think about it, I should have actually supported the sophomores. I do have one of those so say that yellow vest you have. I actually have one of those when I go out running in the morning. I should have wore that. I left it at my house. Yeah, I have one just like that actually. No, I should have worn that with this. Yeah. Oh well. I was thinking of juniors. That was the first thing I was thinking about this morning. Yeah. Okay. But no red. No red. All right. So really quickly here, how do you verify this? Here's what you do. You go to 10. Now cosecant is a little tricky. There's no cosecant in the calculator, right? But how can you kind of trick it to do cosecant? What would you do? Yeah, do 1 over sine. So I'll do times parentheses 1 over sine. What goes inside of that? 3x plus pi. Now you kind of see why it's kind of that old operating system because you can't see what you typed in already. So you have to take a little bit of faith. Or you could do this, by the way. If you so desire, go to classic just for a moment. So now I can see everything I'm typing, right? Isn't that kind of nice? There's an advantage to it. Okay, now you gotta be incredibly OCD with your parentheses. Put another parentheses and raise that to what power, guys? Yeah. Be very OCD with parentheses, or otherwise it's gonna be screwed up. If I didn't put that extra parentheses, what if this was the fourth part then? The 3x plus pi, not the 1 over sine. Can you turn off lights, please? Thanks. Yeah, so you gotta be very mindful about that. Oh, so much. Oh, one more, please. Yeah. Great, awesome, thank you. Yeah, so that's what you gotta do. Now, what do you do as y2? Yep, and deriv. Now, the only thing that's kind of crappy is that, well, I don't want to do that. So I'll go back to mode. Now I know I typed it incorrectly for y1. Okay, all good. Let me clear my screen for a moment because it's getting a little distracting here. Okay, that's x. What do I put here? Alpha trace y1. X equals x. And then actually type in the derivative, which I got negative 120 times. Now remember, it's 1 over sine. 3x plus pi. Raised to what power, guys? Good. Times. And what was the next one? Was it cotangent? Damn it. All right.
That is sweet. That's fine.
Did you bring the negative?
I think I forgot. I think I forgot, guys. This is why this is kind of crazy when you do it this way sometimes, without the wraparound.
But I thought it was cosine.
I already did cosine. I did 1 over sine. So let's go back to mode one more time. I was kind of taking longer than I thought. But here we go. Oh, I got the negative. I'm good. Yeah, I'm good. I'm good. Because I got 1 over sine raised to that, 1 over tangent. Yep. Okay, so now let's turn off y1. And that's just annoying now. Let me go back to the math print. But before you graph, make sure you're in radian mode. And I'd probably do zoom trig, just so it does a trig window. Okay, it's kind of crazy actually. Why is it taking a sweet little time? Because trying to graph the derivative of a pretty complex function, right? So maybe while this is happy, you can work on another problem, right? Okay, so it's taking a sweet little time. Now it's doing the right side.
Maybe it works.
How do you interpret?
Yeah, what if this is in there?
This is y2. No, y3 should be y3 should trace it.
Like radar trap. Kind of.
Because he did it on.
What did you do for that?
Okay, should I see a new graph? No, I should not see a new graph. I should see the same exact thing. I'll show you, Thomas. Give me a sec. Okay, now it's done. If I hit trace, see it says end deriv. If I hit the down key, it says the same thing. You see, it's basically giving me the same thing if I go back between y2 and y3. Another thing I could have done too, I could have actually made y3 a thicker line, just so it shows the tracing. I don't want to do it again because it took too long, but you can verify your work that way, just so you know.
So how do we look to see if which one's not?
When I back to the graph,
The second derivative.
Okay, let's do it over.
Y2 and Y3.
You hit trace, and y2 will show up in the top left corner. Hit the down key to go to y3. It should be on the same place. It should show the same points on the curve. So it shouldn't it's basically you'll see that's retracing itself. That's what you want.
Shouldn't Y2 and Y3 be the same?
They are the same. They were right, exactly. When I did that, I was on the same thing. Laura, go ahead. Actually, you can do you can do that too. That's actually not a bad idea. 100%. Okay, there we go. Now I feel better. See how it's retracing it with a thicker line. So that's what I should have done initially.
That's why.
That's y2 is retracing. So no, y3 is retracing y2. I turn off y1. Okay, I'm getting kind of annoyed about it, so I'm gonna turn it off. Here we go. It's kind of annoying. So expect that. Another thing too, guys. Linear motion. I'm gonna ask a question on linear motion. I have to ask a question on linear motion. So expect something like number 5 on this old test. Expect something like number 6. I love number 6. This is the test review packet. Actually, this is a great test. I love this test. So I'm going to design it pretty close to this one, but I couldn't ask like B or C because we haven't done those functions. So anyway, I still have to write this test. I'll try to put more details. Maybe what I'll do is I'll put some bullet points in Schoology under test number 4, and maybe I'll make a little video, either when I have a free time or whatever, to explain it. But just want to give you an idea of what to expect. So definitely expect that problem I just did. Expect limit definition derivative. Expect linear motion. Expect some of the continuity differentiability. This is definitely a good test. You see right here. I also feel the test I gave last year is a good example, so I could do that. Let's go back. Do I have the answer key for that one? I'll be a little disappointed if I don't. Darn it. What was I doing when? Oh, wait. This is the real test. Hold on. Okay, I did cover more material. Okay, I'm not sure what I just showed you guys. That was a weird. Okay, this was the real test. Oh, wait. Oh, this is another test. Oh, weird. Why did I break those 2 tests? That's weird. Why did I do that? Okay, well, I'll print both. How about that? That's weird. Okay. I don't know what the heck's going on last year. Okay, anyway, this is a good test also. So I'll produce this as well. So I'll produce more tests for you guys, tests from last year. So apparently I broke this up into 2 separate units. I don't know why. Couldn't tell you. So anyway, you guys use rest time to work. We still got another hour or so. All right. Our test will be an hour long. All the classes are 75 minutes throughout the whole week. Yeah. All right, I'll stop there.